welcome to chemistry here at Spain Park High School. Today is Tuesday, February the 21st. Wow, it's February 21st. Okay, and if you're enjoying these exciting videos, feel free to subscribe to my channel and hit the like sign. Okay, I'm almost to 100. So I'm going to start getting some money here pretty soon. Okay. Get out on Friday we did the s'mores activity. So let's get out that sheet and let's talk about what that meant. And I told you you did not have to do that question number 3, but now we want to be able to do that. Okay? So let's put our electronic devices away. Okay? And let's focus in for these few minutes that we have.
I left mine downstairs.
I will get you one to look.
Thank you.
So what we are working on is what we call stoichiometry. And as I'm putting this up, we need to say a little prayer for Miss Frederick. She's not feeling well today, so she had to call in sick. So hopefully she'll be feeling better. So when we did our s'mores, what was the equation for a s'more? What was our balanced equation?
GC2.
Well, it was GC, and we needed 2 of them, right?
Yes.
Okay? Plus 1 marshmallow, plus 2 pieces of chocolate, and we got our s'more. Right?
Mm-hmm.
So the goal of what we really want to do is, what does this tell us? What do we know? Well, if I wanted to make 10 s'mores, if I wanted to make 10 of them, how many graham crackers am I going to need? I heard you. 20. How do we know that?
2 times, we have to have 2.
Because for every 2, we only get 1, because we need two graham crackers for every s'more. So I'm going to need 20 graham crackers. How many marshmallows am I going to need?
10.
10. And how many pieces of chocolate am I going to need?
20.
20. So if I go to a raging party, have a huge bonfire, and I want to eat 1,000 s'mores,
Jeez.
how many graham crackers am I going to have to buy?
2000.
2,000.
2,000. How many marshmallows am I going to have to buy? 1,000. And
2,000.
2,000. And let's do it in a little bit different terms. Let's say that I want 10 dozen s'more.
10 times 12.
Okay? But how many dozen graham crackers am I going to need to buy?
2 dozen for every word.
So if I need 10 dozen, how many?
20 dozen.
I need 20
20
dozen, right? Okay, because a dozen and a dozen is 12, so I just always need twice as many, however many I'm measuring. And so how many dozen marshmallows am I going to need?
10.
10. And how many dozen pieces of chocolate?
20.
20. Okay, so now let's put this into some chemistry terms. Because in chemistry, we do everything in terms of moles, right? So if I want to make 10 moles of graham crackers, that's a lot. 6.02 times 10 to the 23rd times 10, or 6.02 times 10 to the 24th s'mores. It's a lot of s'mores, but how many moles of graham crackers am I going to need?
20 moles.
20 moles. And how many moles of marshmallows am I going to need?
10 moles.
10. And how many moles of pieces of chocolate? 20. So no matter what, as long as, I'm comparing equal amounts here, it's always the balanced equation gives me the recipe, the ratio in which I need to combine everything, right? Now, Does it mean that I need 20 grams? Did a box of graham crackers weigh the same amount as a bag of marshmallows? No, they had different amounts and whatever, so they don't weigh. A graham cracker, marshmallow, and the chocolate did not weigh the same, so it's not going to be 2 grams of graham crackers. It's not going to be 1 gram of marshmallows and 2 grams of chocolate. It's not a gram ratio. It's a numbers. It's a two of these plus 1 of those plus 2 of those, or 20 to 10 to 20. Okay. So if I want to apply that then to just, let's say, a chemistry equation, 2 hydrogen gas plus oxygen gas makes 2 H2O liquid. So if I want to make, let's just say, 10 molecules of water, if I want to go to the hydrogen store, how many molecules do I need to buy? 20. And how many molecules of oxygen am I going to have to react with it?
20. Or no, 10.
10, oops, I said it's 20. 10 molecules of oxygen. But again, so if I want to make 10 moles, how many moles of hydrogen do I need?
20.
20 moles and 10 moles. But what it doesn't tell me is it's not going to be 2 grams of hydrogen and 1 gram of oxygen. Oxygen is going to weigh a whole lot more, right? So this is going to tell me that 2 molecules will combine with 1 molecule to make 2 molecules. Okay? And if you just want to see that, I mean just 2 hydrogens combined with 1 oxygen. So this bond breaks, this goes into here, that one comes into there, so I end up getting 2 waters, right? So, I mean, we're just showing the ratio in which they're combining, but I can combine them as long as, no matter how much hydrogen I have, I only need half the amount of oxygen. But if I go to 2 moles of this plus 1 mole of that goes to 2 moles of this, okay? Well, what's 2 moles? How much does 2 moles of hydrogen gas weigh? How do I know that? I see everybody looking at the periodic table. How do I find out what 2 moles of hydrogen gas?
2 times the.
Okay, so we go and we look at hydrogen, it's 1.01. Since it's H2, come on, y'all, 1.01 times 2, 2.02, right?
Right.
But I have 2 of them, so that means 4.04 grams of this will combine with 1 mole of oxygen,
So
which is going to be
16.
well, 16 times
2, which is
2,
32.
so it's 32 grams. And how much should it make?
36.04.
36.04. Now there's 2 ways to get that number. Number 1, the law of conservation of mass. Atoms are neither created nor destroyed, right? So the products is always going to equal the same amount as the reactants. However, if you recall, the molar mass of water, 16 plus 2.02 is 18.02 times 2 is 36.04. So 4 grams combined with 32 grams to make 36 grams, but that's not a 2 to 1 to 2 ratio. The balanced equation tells us the mole ratio, not a gram ratio. Right? So everything that we're going to do revolves around the balanced equation. That's our recipe, but it's all in terms of moles, not in terms of grams. But we don't measure moles, we measure grams. So we're going to have to take everything from grams to moles. Okay? So now let's look at that number 3 on your sheet.
Wait.
Number 3 on the sheet
Okay.
at the bottom. And it says,
Is this one about copper?
yeah.
If you begin with 15.2.
Well, yeah, so let me get this up here first. Come on, come on, come on, come on. Come on, people now. Okay, are produced. All right, so first thing we have to do is we have to balance this equation. Is this equation balanced?
AG, 1 AG, 1 AG. And now
yeah.
there's 2 in there.
Don't say the answer out. Take 10 seconds, 30 seconds, and let's just go ahead and balance it on your sheet right there in front of you. We already do that? You can go ahead and write on that one, Rocco.
Okay. Well, we already did that.
Hey, do you not have your sheet with you? Yeah, you.
Oh, I do have it.
Yeah, let's get it out and let's put that away. Do we get it?
Yes.
Okay, so now the way I'm gonna balance this one, and you know, everybody's got their own technique, but I'm just gonna go left to right. One copper, one silver, one silver. But I know that that is a polyatomic ion, and that's real important. I didn't make you memorize them, but you have to be really familiar and be able to at least recognize that NO3 is a polyatomic ion, that's nitrate. We've used it a lot. So treat it as a single thing. So I have one nitrate, but I have two nitrates. So I don't break up the nitrogens and the oxygens here. I just say two nitrates. So I need two nitrates. So I got to put a 2 out in front. Now I have two nitrates, but now I have two silvers. So I have to put a 2. Okay? So now we have a balanced equation. But I have 15 grams of copper, but what's it asking for?
How many grams of silver?
How many grams of silver? Okay? But what's my balanced equation tell me? For every 1 copper, 2 silver. Is that for every 1 gram of copper I get 2 grams of silver? For every 1 atom I get 2 atoms. Or for every 1 mole I get 2 moles. So what am I going to have to do with this 15 grams of copper in order to be able to convert between the two?
Well, you're going to have to get them equal, right?
Okay, again, the balanced equation tells me what ratio?
2 to 1.
2 to 1 what? 2 of what to 1 of what?
2.
2 moles to 1 mole.
Right.
So what am I going to need to convert 15 grams to?
Moles.
Moles. How do I do that?
Start with 15 grams.
Okay, so I have 15 grams of copper. How do I convert that to moles?
Well, you need to put, so 1 mole equals how many grams? 1 equals.
How do you know how many grams 1 mole of copper is? Periodic table. So you go to element number 29.
1, 2, 3, 4, 5. I can't see that far, but
63.55, 63.546, 63.55. And why am I putting grams on the bottom?
because you have to cross them out.
Because the grams on the top there. So if I stop right there, that tells me how many moles of copper I have.
Right.
Now the balanced equation tells me for every 1 mole of copper, I can make 2 moles of silver, assuming I have plenty of silver nitrate to react with it. Right? So now I can say, okay, well I get 2 moles of silver for every 1 mole of copper. So now my moles of copper cancel. So if I stop right there, what's my unit going to come out in?
Yeah, 15
Not what's the number, what's the unit?
moles.
Of
Silver.
silver. So I would know that 15 is just a little bit less than a fourth. But I'm going to got times 2, so I'm almost going to make about a half a mole of silver, give or take. I mean, I'm just approximating. Okay? But I want grams. So now how do I get from, if I know how many moles of silver I have, how do I go to grams of silver? Again, the periodic table. So element number 47.
40 said, I can't read that far, but it's
107.9.
Yeah, I was about to say.
This time though, I'm going the other direction, so moles is on the top, moles goes on the bottom. Now I have grams of silver, which is what the question's asking for, so I know I can stick a fork in it, I'm done.
Oh, I see what you're saying now.
So now this is just like when we did, way back when we did conversions. On the top you multiply, on the bottom you divide. Make sure we can do this on your calculator. 15 divided by 63.55 times 2 times 107.9. I do believe it comes out
They
there.
need a camera on calculators.
It's called a phone.
They're not that fancy.
Okay, so what do we get? 50.936,
Yes.
Yep.
which would be the 3 sig figs.
50.9.
50.9. 50.9 is 3 sig figs. Grams of silver. Okay, so that's stoichiometry right there. Given 15 grams, assuming I got plenty of silver nitrate. Now another part of this question could be, well, how much silver nitrate do I need? Because if I'm in the I'm in the real world, I'm at a factory, I need to know, okay, well, how many tons of this one do I need to combine with how many tons of that one? What ratio do I need to combine them in? And then how many tons of product should I expect to get? This is telling me how much I should expect to get of silver if I combine these two things together. That's what stoichiometry is. Okay? Now, there are 4 simple steps to solving a stoichiometry problem. What time are we out of here? 8? 108?
By the way,
Okay. So, these are going to be basically what I'm about to give you right here is going to be your whole notes for the whole unit. Okay, I'm giving you 90% of the entire unit right here, what I'm about to do. And it's going to be like this part of a board. Okay? Step 1, write a balanced equation. We already know how to do that. Oh, let me first before you do that. Sorry. 4 steps to solving a stoichiometry problem. Okay? Step 1, write a balanced equation. Now that's why we just did the unit that we just did. Because without the balanced equation, we can't do stoichiometry. You're fine. The balanced equation is our recipe. So we have the basic recipe. Now we need to put it into practice. Okay? Because you don't have to make just 1 or 2. As long as we have the ratio. I make some killer oatmeal chocolate chip cookies. I had my men's small group for last night, and I made some cookies for them. And I know 3/4 cups of white sugar, 3/4 cups of brown sugar, 7/8 of a stick of shortening, and that's the magic ingredient, which makes it totally unhealthy. Okay, 2 eggs, teaspoon salt, teaspoon soda, teaspoon of vanilla, 1.5 cups of flour, 2 cups of oatmeal, some chocolate chips. Bam! I can mix them all together. But I could double that recipe, I could triple the recipe, I could half the recipe. I just know the ratio I need to combine everything in. And then I know that I should expect to make 36 cookies from that recipe. Okay, if I double it, I should expect to make 72 cookies. Now, unfortunately, generally I only make about 33 cookies come out of my batch because the batter just really tastes good raw. And so it never makes it to all 36. But that's neither here nor there. That's what we're going to talk about on the next end. Okay? So I have a balanced equation. So I have the ratio. I have to have this in order to be able to know the ratios and what to combine with what. But it doesn't have to be, it can be any amounts. So number 2, I always say just the facts. there was an old TV show called Dragnet. And there was two cops, and they were, I mean, this was like the 50s and early 60s. It was black and white. It was a detective show. But they would always go, and they were very uptight, you know, and crew cut and all that, wearing a skinny black tie. But they knocked on the door, and they always have this lady. She'd always just be kind of going off on a tangent. And on every episode, the guy would say, "Just the facts, ma'am. Just the facts. You know, I don't need all of that other side information. I just need the facts of what happened." That's what we need to do. There's a lot of, big word here, superfluous information in some of these problems. Does anybody know what that word is? Superfluous.
Not good.
Say what?
It's a whole bunch of info, stuff you do need, stuff you don't.
There's a whole bunch of stuff, and most of it you won't need. Superfluous, super, above. Super fluent, okay? Just way more fluency than what you, in other words, a whole bunch of stuff to wade through. What we really need to know is what's given and what are you looking for? Because if you don't know what you're looking for, you'll probably never find it. It's deep. If you don't know where you're going, you'll probably never get there. If you aim at nothing, you'll probably hit it. And the oxen is slow, but the earth is patient. Now that has nothing to do with it, but I just thought that one was cool. So, you gotta know what, so in this problem, what are we given and what are we looking for in this problem?
We are given.
In this problem here that we just did.
15 grams.
We're given 15 grams. That's my given. What am I asking for? What's it asking for? How many grams? That's my unknown. Once I have my balanced equation, I need all of this to get the ratios, but once I have the balanced equation, I'm only concerned about my given and my unknown. I'm assuming I got plenty of everything else. I'm just not worried about the other stuff. My given and my unknown. Now step 3, and I like to do this. I just like to put it right either above or below, right on that balanced equation. So, I mean, it's just real obvious. And I like the unit, so I know, am I looking for grams? Am I looking for moles? We're gonna be looking, as the year progresses, we're gonna be looking for different things. So, step 3, determine, and this is more of a mental step, determine the mole ratio between the given and unknown. And it's always going to be moles of unknown over moles of given. That's this step right here. That's the only step for us that's new. That's the only part of this process, this all stoichiometry, this entire unit. The only thing that's new is us using this mole ratio. We already know how to go from grams to moles. We already know how to go from moles to grams. We already know how to write a balanced equation, right? Theoretically, okay? So we have a balanced equation. We have our mole ratios, okay? So we're just adding in, kind of putting it all together and adding in that mole ratio. So, step 4, solve the problem. Using, okay? Now, I don't have room. If I go down here, you're not going to be able to see it. So I'm just going to go up top. And I'm just going to cover this up. I just messed that up a little bit. Let's get right back where it was. Close enough. Okay? Let's see if I can get a little bit better. There we go. How did that get so far off? Okay, so we have a 2 and a 2. I have 15 grams here, and I have X grams there. Okay? So, I'm gonna always go, so this is going right under, this is going right under here, okay? So using the mass of the given to moles of given to moles of unknown to mass of unknown. That's going to be our catchphrase for this entire unit. Mass to moles to mass. Mass to moles to mass. We're going to say it so often, we're going to know it forwards and backwards. Mass to moles to mass, or say it backwards, mass to moles to mass.
Moles.
Okay? So how do we go from mass to moles? What did we say? How do we go from here, mass to moles? How do I convert that? What do I use? The periodic table, what's the specific term for when you add up the weights? Atomic mass for an individual element, but for a compound it's called
Atomic number.
molecular mass for a compound, or a formula mass, but together our umbrella term is the molar mass. But of the given. Okay? And so how did we go back from moles of unknown to mass? What was this?
Same thing.
Same thing, the molar mass, but this time of the unknown, right?
Right.
So, this is the only step that's new. How did we go from moles of copper to moles of silver?
Yeah, flip them. Well, you
What
got-
did we use?
You use the
What was step 3? Use the mole ratio, right?
Right.
That's why we need the balanced equation.
Gotcha.
To know what's the ratio, what's the relationship between my given and my unknown. Is it 1 to 1, 2 to 1, 5 to 2? What's the ratio? And that's just the coefficients for the balanced equation. So this is the mole ratio from the balanced equation. Okay, it's just your coefficients. Okay? Determine the mole ratio. It's the coefficients from the balanced equation. So if you need to put that in there, coefficients, this mole ratio, that's just your coefficients for your balanced equation. So notice, we have a balanced equation. Just the facts, 15 grams of copper, how many grams of silver? It's a 1 to 2 ratio.
That's the bell. Is it?
Is that the bell?
No. Yeah, 400.
It isn't.
It's a bomb. Oh my god. Sorry, I'm
Oh, it's one of those timers that I was messing with. Okay, I'm not sure what that means. I put a new battery in, and I couldn't make anything else work, but apparently the alarm works. All right, so the mole ratio, we can take the grams to moles using the molar mass of the given. Then we go from moles of given to moles of unknown with the mole ratio, always with unknown on top. That's just your coefficients from the balanced equation. That's why we have to have the balanced equation. So this is just your coefficients from the balanced equation. Notice the molarity is always per 1 mole. The coefficient doesn't matter in the molarities. Molar mass is always 1 mole. The only time we're going to use the coefficients is in this mole ratio. So all we're going to do is, for the rest of the week, is just practice now just doing this mass to moles to moles to mass. Now here's the deal. We can use, this was given this, figuring out how much product. We could have had this, we could have made this my unknown. We could have given this, I could have asked, well, how much silver nitrate does it need to react with it? Yeah, I could be given, okay, well, if I want to make 25 grams of silver, how much copper do I need? Doesn't matter if the given is on the right, you do everything the same. Mass of the given times the moles of the given, to convert the moles of given to moles of unknown to mass of unknown. You can go left to right, right to left. You can be given two reactants, you can be given two products. You can, anything in the balanced equation. It doesn't matter. Okay? So all we're going to do is we're just going to continue to practice going through this process. It's at 108, right? So I wanted to do one more example, but we're out of time for today. But coming in tomorrow, all we're going to do is just work practice problems and do examples of these. Now apparently a lot of people are going to be out on Friday. I really had a lab scheduled for Friday.
Wait, why are people out on Friday? What's so big?
Auburn E-Day, Engineering Day.
Yeah.
So all of the Engineering Academy kids are going, and anybody else that wants an excuse to get out of school is going to go.
Wait, you don't have to be in engineering to go?
No, I'm sure, but I mean,
Well, we've been notified about that.
yeah.
I'm not going.
So anyway, we'll practice, but those that, so I don't know, we'll probably do the lab then on Monday.
Sounds good.
Okay? All right. Have a great day.
All right, thanks.